Second plane is control plane. What is control plane? Actually, traffic from device to device is called control plane traffic. Control plane traffic means the communication between device to device. Either the communication, when there are a lot of traffic which generating by device itself, like CDP, LLDP, ARP, OSPF, RIP, BGP, EIGRP. All these are generated automatically by the device. So this type of traffic is called control plane traffic. Either communication between device to device, maybe router sending hello to another router. Like maybe you discuss an OSPF and RIP, they are sending hello packet. So we never give them instruction to send. Neither as a user we send this hello packet. Basically these devices are generating this traffic. So we need to secure control plane as well. We discuss a management plane. There are three types of plane, as I told you. Management plane, user to device traffic. Control plane, device to device traffic. And data plane, user to user traffic. Normally in real world we are spending thousand and hundred and thousand, million and million only on data plane protection, but nobody care about control plane and management plane. Keep in mind, data plane we will discuss within, I will tell you there. Like firewall, IPS, IDS, all these we deploy for data plane, user to user traffic. When user sending the traffic to Google, Yahoo, Facebook and outside and inside organization, this is data plane. Management plane, when we sending the traffic to the device to configure it. And control plane, when one device send the traffic to another device. Like as I give an example of CDP, LLDP, ARP, OSPF, RIP, BGP, EIGRP, ICMP. All these coming under device to device traffic. And also a lot of traffic is generated itself by the device. So we need to protect these type, because if somebody try, they can manipulate this traffic device to device and they can down our network. They can use CDP attack, they can use LLDP attack, they can use ICMP attack to increase our RAM, to high our CPU and can down our devices. So it means beside management plane protection, we need control plane protection as well. It's enough, you understand what I'm saying. These are, I give an example. Now what we can do, so fortunately there are two things to secure control plane. One is control plane policing. Control plane, we are discussing control plane, and policing means police, like a police officer. So there will be a police officer, they will protect the control plane. And another one is, this is a subtype of control plane policing, is control plane protection. Both are the same thing, almost. It's like a subtype, like a feature. So these two things you can use to protect your control plane. And it's a built-in command only in your Cisco OS to protect your device, not to generate huge traffic. And if somebody manipulate the device to device traffic and increase it, so these two will care about the traffic. So like a CPU handling, like a RAM handling. I will give an example, you will understand what I am saying. So basically two things, control plane policing and control plane protection. These two features should be enabled to protect your control plane. So let me show you how. So I'm here, this time I'm using Eve. You can use GNS3, you can use Eve, it's up to you. Okay, so let me take a router, any router. I take this router and let me change the name to R1 and it's okay. So I take this router and let me take a Kali Linux. So type Linux, okay, and from here I will take Linux Kali, and here let me change them to something else. Okay, let's take this one and change the console from VNC to RDP, so it will be easy for us. Okay, so this is Linux. Okay, and let me connect to router any interface. Okay, and either, okay, let me do one thing, because we will do 2 lab, so why not let me take another router as well, just to show you from 2 different scenarios. So why not, let me take R1 as well. So 1 lab we will perform in 1. Okay, let me take this as a R2, and let me take a switch in the middle. So let me go to ILO, and let me take a switch from here, because switch will be not by default, so switch, and change the name to switch, something at least we know. Okay, and now I will connect here. So in this way we will do 2 lab, so that I can show you properly control plane. And let me connect here, and this one to connect second router. Okay, let me on this one, and let me on this one on, and let me start Kali Linux. Okay, we can use any subnet, by the way, until on the devices. So let's take 1.1.1, and let me give them any color. So we will assign 1.1 to R1, and we will assign 1.1.2 to R2. You can take any range, by the way. And third one we will assign 1.1.10 to Kali Linux. Okay, done. So let me configure this one, R1 first. So type no. Okay, and until it's coming, let me open this one as well. Okay, and let me type here no as well, because in Eve it's take time to boot the device, so it's better to, yeah, so it's come up now. Configuration, host name is R1, and I'm using interface fast Ethernet 0/0, IP address 1.1.1 255.0.0, no shutdown. Okay, and do right, save the setting. Go to R2, configuration, interface fast Ethernet 0/0, IP address 1.1.2 255.0.0, no shutdown, do right, and let me change host name R2, do right. Done. My 2 routers are ready, and why not just ping, because we are connected directly through switch, so it has to work. 111, yeah, so it's working, so I can ping R1. Done. Now let's go to Kali Linux and assign IP there. By default, Kali Linux username is root and password is Tor, opposite, root and Tor. Okay, from here I just want to do 2 type of attack, and then we will protect control plane. That's why I'm here. So first I need to assign IP, so click here and go to Ethernet 0/0. Okay, and wire setting graphically, no need to do it through command, you can also do it. Click on this gear icon, go to IP4, and instead of automatic, manual, and type IP 1.1.10, which we decide 255.0.0, and no need of gateway, we are directly connected. and no need of DNS, and apply the setting. Okay, connect and disconnect one time so that we can get the IP. Go to terminal and type fconfig. Better to type fconfig EH0. Okay, so 1110. Let me ping 111. Yeah, I can ping 111 and I can ping 112 because we are directly connected. Control L. Done. Good. Now let's do a UDP flooding attack on this device R1, and then we will protect this device. Right now, no CDP run. If I check show process CPU, okay, so I'm using only 0% of CPU from last 1 minute, and 5 minutes 0%, because there is no such thing coming on this device to process, so my 0% CPU is utilized. Why not? Let's see debug IP UDP. Let me on debugging. Debug means show me behind the scene traffic. Normally we are not using this in real world because this requires more CPU, but just to show you for the lab purpose, I say debug IP UDP. Show me all the UDP traffic which coming to this device. Right now there is nothing. Let me go to Kali Linux and type hping 3. This is a utility we use in Palo Alto course and also in Cisco SA course. Those old students, they know we use most of the time this one. And type flood. You can take a question mark here to find out the help. It's not difficult. Here everything is mentioned. Also example is mentioned. And even if you type manual or something, I forgot what was beside help, there is another one something. When you type, they will show you all the detail. Anyway, so let me say hping 3, and I would say flood, and with random source. You can type tab, it will auto complete. And which protocol? UDP. And with port number, any port, just give me 445. On which IP? 1.1.1, which is R1 IP, and enter. So what I done, this UDP, sorry, I written wrong, UDP. Now it started, and let's go to R1. Look at R1. Huge traffic is coming to this device, and after 2 minutes it will crash. So let me stop it, because I know I performed this lab many times and sometime has crashed the device. That's why I saved the IP. And if you run this for 2 minutes, this device CPU will be 100% utilized, and RAM will be also almost 80%. And when you try to ping this device from proper server, it will not work. Like before, we try from here. No CDP run. Forget about no CDP run. Basically this CDP duplex mismatch is coming. That's why I'm disabling this. It means stop the attack. So otherwise, if you try, it will not ping because they don't have any more CPU and RAM to utilize any traffic. So huge traffic is coming from random source, because they say random source and destination is 11. This the port number I give them. You can give any port, and this the random IP. Look at random, and show process CPU. I know it will be down now, but when you check it, so it will be 100% utilized. It will be 100% utilized, and it will show you that it can do nothing. So this is coming under control plane. How you can protect this device from such type of attack? Control C. So you can use control plane policing and control plane protection, which I told you two way. How? Let's do it. For control plane policing, basically you need three things. And I believe we discussed this in Cisco SA firewall as well. First thing, you need ACL to help you. Basically three things require for control plane: class map, policy map, and control plane. class map to identify the traffic, which type of traffic you want to stop or allowed. This is called identification. So for that purpose we are using class map. Second is policy map, to call the class map and take action on it. And the last thing is control plane, to apply this policy map there. So it means basically these three things are interconnected. You will call class map and policy map will be called in control plane, and this way they will protect your control plane. But ACL basically helping class map to identify traffic. Like in our case, which type of traffic? It was UDP traffic. So what I can do, I will say IP access list, either standard or extended ACL, or you can use name ACL, and extended here I will say test, whatever name you want to give. I will say permit UDP any to any, because I want my specific target is UDP, and this way you can protect all the protocol, but I'm just showing you two examples. One of them is UDP. This done. So my my access list is ready to help who? Class map. First thing is class map. Let me give them C map, just the name. C means class and map means map, just for easy understanding. So I create a class map with the name C map. Now I will call match access group. Yeah, here I will call my ACL. You can call number ACL and name. So what is the name? Test. Done. That's it. Name and then test, and exit. This was the first thing. Class map is used to identify the traffic, and ACL help it to identify the traffic, and traffic is UDP, and source is any and destination is any. Done. First thing, I identify the traffic. Now I will take action. For action I need policy map, and I will give the name P map. You can give any name. Now I will call class map. What was the class map name? C map. That's the C map. And now I will take action. So I will say police, and here how many bit per second? So I'd say 8,000. 8,000. Confirm action, transmit, and what is the other thing? Yeah, exceed action. So there are many action. I will say drop. So now I take action on class map that if the traffic is increasing more than 8,000 bit per second, drop them. If it is under 8,000 bit per second, it's okay to allowed. This the action I take on class map, and class map I say UDP, any to any. Two thing. And exit from here. Let me generate logs so that we can see. I say logs, exit and exit. Third thing, to call this to take action on this policy map, and that is control plane, which is our target. So I say control plane, and here I will say service policy, and service policy I would say input, because it will come in. And what is the policy map or policy is P map. So basically I call class map and policy map I call in control plane, and that's it, and enter. So done. And now how can I check? So show policy map. There is a command, show policy map something. Yeah, control plane. This is the command. So I say show policy map control plane. So they say there is a policy map. Okay, and policy map say if the 8,000 bit per second is increased, so what to do? Drop it. Action drop. And if it is under 8,000 bit per second, confirm, forward it. So there is nothing, confirm 0 and also drop 0. That's it. Why? Now I will generate. And also I enable logs, so you all disable those debugging, because now I enable logs as well. You know, you remember show running section policy map. Here I enable logs. So I say whenever somebody hitting, just show me the logs. We will discuss log in detail, syslogs. Anyway, now let's generate again the attack. Tor. Let me log in again and try now. Now you will see the difference. Now there is is allowed, then is drop. They say drop. Few are allowed. If it is increasing more than 8,000, so they say drop. Look at drop by control plane. So now control plane is protecting our device from such type of attack. After a while you will again see drop. So let me stop the attack to show you. Control C and let's go there. Here is. So you can see it say drop control plane policing from random source, because it was increasing more than 8-bit and drop. And let's go back to show running configuration. No, sorry, the other command, show policy map control plane. And here it say that 780 packet has been forward action transmit, and 809.135 packet which become like that much byte, we take action and confirm these is being dropped. And logs are there, you can see the logs. And also you can see show logging. Okay, it's not showing in this router. It will show you the logs here as well, the last most recent logs. So it's here as well. So this is the way to protect your control plane. And to protect your control plane, you can use control plane policing. So I use them for for UDP. Now let's do another lab in R2 the same way, but this time rather than UDP we will use another one is ICMP, because ICMP is also coming under control plane. And we will create such type of policy, exactly the same thing. Anyway, let me show you. So what I need to do, let me go there, and this time I will go to R2. So nothing is configured there. First thing first, I need access list. So IP access list extended and ABC, whatever you want to give them the name. And permit ICMP. ICMP means Internet Control Message Protocol, means ping any to any. Exit. First thing first, I need class map. Class map CMap, and here match access group. What is my access group name? So ABC. Done. So we identify the traffic will be ICMP. Okay. Now what I need, class map. Sorry, class map we done it. Policy map. So policy map PMap, and here we will call class map, so CMap. And either before do attack, then we will test. Okay, let me configure, but I will not apply. Then I will show you the attack, then we will block it. So class map, I call class map, and here I will say police, same like that one, 8,000 question mark confirm action, and transmitted if exceed, so then action take drop. Okay, exit and on logs and exit and exit. Now the last thing, but I will not apply yet, control plane, but here before the attack I will not apply. So let's do attack from here. This time I will say hping flood random source, but the protocol is not UDP, ICMP. And sorry, not the IP is not 1, this time is R2. And now you will see a huge traffic, but how to see it? So type debug IP ICMP. Look at a huge traffic is coming to this router and nobody has to stop them. So let's go back, Control C, and now let's apply protection. You know, it's continuously sending and receiving, and even the router is almost stuck. It will stuck. If you run it, you can try in your lab. Just run it for 2 minutes and you will see the difference. I don't want, because it will stuck and everything, and then I will reconfigure everything. And your router will be CPU and RAM will be high, almost 100. So let wait, is still coming because it's a huge traffic they send. So I cannot type anything until it stop. So just wait a minute, then I will apply the same thing which I already configure. Yeah, it's done. And now what I can do, configure, let me disable logs, debug. This was debug, control configuration of, and what was control plane, and now I will apply. So service policy input, and policy map name was pmap, and that's it. Because I enable logs, so I will see everything. And from here, let me show you first. Show policy map control plane. So this time policy map is for ICMP. Okay, and if you see this, the ABC, this my access list we call it. Still there is nothing, 0 and 0. Now let's generate again, and now let's go. Look it, so it dropped by control plane. These one is drop, and then allowed, then again drop. Let me stop and show you. Control C. So in this way your device will be protected. Okay, where is, okay, I have two. What the hell, I have, okay, basically I have two, so I need to, this one, yeah. Okay, so here you can see this being dropped by control plane, and these are allowed. And how we can verify? So if you go there, so it will say that these are 414 packet which become 17388 byte. It's been transmitted, and these been exceeded, that's why we drop it. Okay, this the simple thing. Just I give you two example, but in this way you can put restriction on many protocol. When you go to policy map, you will find many things to protect which is related to control plane, and this way you can protect your device from such type of attack. So this is called control plane.